You're here because you want to master the periodic table and periodic trends with a University of Cambridge graduate. This is actually part 1 of our periodic trends chapter. If you want to watch the future parts, be sure to check out our playlist below. Hi, I'm Brendan, and I'm a University of Cambridge graduate who has been teaching chemistry to many students like you over the past 9 years. I'm also the founder of the Chemistry Institution, where we have helped many students improve in a short amount of time and achieve the grades of their dreams. Be sure to check out our website in the link in the description below so that you can download a free copy of the notes for yourself and use it to run through this lecture with me today. So we've already learned about the periodic table in the very start of our chemistry journey already, and this chapter we are going to break down deeper into some of the properties of the periodic table and some of the trends in your periodic table as well, such as when you go across the period and if you go down the group, what properties do change amongst the elements itself. So just a refresher for what the periodic table has. The periodic table consists of elements that are actually arranged in increasing order of the proton number, and the horizontal row is what we call a period. So the period is the one that indicates the number of electron shells in the atom of an element. For example, if the element is in the second period, that means that this element itself has 2 electron shells. And the elements in the same period have all the same number of filled electron shells. The vertical column is called a group. The group number can be used to determine the number of valence electrons in the element. So for example, let's say we have an element in group 13, and if it's in group 13, this would mean that the element actually has 3 electrons in the valence shell. And this will also mean that elements in the same group have the same number of valence electrons. You're also going to realize that there's actually 3 rows of elements that are between group 2 and group 13. Alright, these elements belong not to any specific group, they actually belong to this group called like the transition elements. Next, let's take a look at some periodic trends that we can find in the periodic table. For instance, when we move across a period from the left to the right, okay, you will see the proton number increasing. Now let's use an example of sodium, okay, on the left of period 3, moving towards the right, where you'll find argon, and you will see that the proton number increases. For sodium, the proton number was 11. This increases across the period, right, from sodium to magnesium to aluminium, and then it goes all the way until argon, okay, which actually has a proton number, of 18. Not only that, the number of valence electrons also increases. So for sodium, right, we know that it had 1 valence electron, okay, and because it's in group 1, it will increase all the way until argon, which actually has 8 valence electrons in the outer shell. There is also a gradual change in elements from metals to non-metals. Okay, so generally, right, on the left of the periodic table, you will find your metals. Okay, especially group 1. Group 1, all of the elements are metals, right? And metalloids, okay, are located between the metals and the non-metals. Alright, so metalloids are, for example, like your silicon. And as you move towards the right of the periodic table, these are generally where you find all the non-metals itself. Okay, another trend that you will find is that electropositivity, which is the tendency to lose electrons, actually decreases. Okay, which is very natural because you know that on the left of the periodic table, right, you find your metals, and metals really want to lose electrons, right? Remember? But your non-metals, on the other hand, don't want to lose electrons. They want to do the opposite, which is gain electrons. So what are some of the common properties of elements in the same group, right? For elements in a group, right, they will have these similar properties. They have the same number of valence electrons, because as we knew from before, remember, a group is very useful in indicating the number of valence electrons. So conversely, elements all in the same group have the same number of valence electrons. Alright, so take a look at an example of lithium, okay, and sodium. They're both in group 1, okay, so they have both 1 valence electron each, right? And they, because of this, have similar chemical properties, right? So for example, your group 1 elements, they all tend to react vigorously with water, right, to produce hydrogen gas. And we're actually going to touch on this even more, okay, in the future part where we talk about your group 1 elements. Elements in the same group also tend to have similar metallic or non-metallic properties. So for example, group 1 elements are all metals, whereas your group 17 elements, right, which are your halogens, these are actually non-metals. Elements in the same group also form ions with very similar formulas. So for example, your group 1 elements, right, they will form ions, right, with a 1+ charge. For example, your Li+ and your Na+. And your group 17 elements, right, will actually form ions with a 1- charge, right? So generally, elements in the same group will follow the same charge or the most common charge for that particular group, right? Because remember, all elements in the same group have the same number of valence electrons. Most elements in groups 1, 2, and 13, these are metals, as we have described before, because these atoms tend to lose electrons to form positive ions. So the charge on the ion is the same as the group number of the element, right? So you will see that elements in group 1 tend to have a 1+ charge, elements in group 2 tend to have a 2+ charge, and elements in group 13 tend to have a 3+ charge, right? Versus your elements in group 15, 16, and 17, these are non-metals, okay? Because these atoms tend to gain electrons and form your negative ions. So generally, group 15 elements tend to have a 3- charge, group 16 elements tend to have a 2- charge, and group 17 elements tend to have a 1- charge. So what are some of the properties that actually change for elements going down a group? Right? Let's take a look at an example of lithium, right? And as you go down the group 1, right, you will reach eventually rubidium. So what are the changes? One change is that the proton number actually increases down the group, right? So for example, for lithium going to rubidium, you realize that the proton number increases from 3 to like 37, for example. Okay. Also, the number of electron shells of an element will actually increase down the group, right? Take a look at example of lithium to rubidium again. Since lithium is found in period 2, right, this has 2 electron shells, whereas rubidium actually has 5 electron shells because it is found in period 5. Right. Next, the relative atomic mass of the elements will actually increase down the group as well. So if you look at the AR of the elements, okay, going down the group, for example, lithium has an AR of 7 versus rubidium actually has an AR of about 85.5. Your metallic character of an element actually increases down the group as well. Okay, why is this so? Actually, this is because this is related to the tendency to lose electrons. Okay, so this will increase down the group, generally because you have an increased number of electron shells. Okay, and so the valence electron is further from the nucleus. That's all for today's video. If you really learned something and you like this video, be sure to click on that like and that subscribe button so you don't miss out on free content like this. If you want to join my community of students at the Cambridge Institution, be sure to check out our link in the description below so that you can sign up for a free trial class today. Here you can learn the exact systems that we use at the Cambridge Institution to help our students improve in a short span of time and also achieve their grades of their dreams in the end.